Brothers and sisters, this is Sulaiman Rahim here, and this is a class for the spatial mind, mathematics and science for the spatial mind. It's my intentions on, we told Islam is mathematics, and mathematics Islam. So let me teach you some mathematics, Islamic mathematics, right? I think I may have spelled something wrong. Let me check something, brothers and sisters. I kind of hastily did this. Hold on. I don't want to spell out wrong. I spelled correctly. Okay. So today I'm a calculus. Tomorrow prop. I intend to do this on a daily basis for about an hour. And tomorrow thinking pressure. Speak on pressure. Or perhaps on vectors, the language of force. Anyway, today we'll talk about calculus. Now, the way they've been teaching you, the reason our people are mathematics, they're mathematical people. Right? But you've been taught by people that's not mathematical, and they don't understand, they have some flavor, some idea of math. They don't know how to apply it to their particular situation. They have, their mathematical skills are very limited. Their mathematical knowledge is very limited. Most of it's like theory and carrying on. And so when they try teaching you, it's confusing because they have simple minds complicate, and complex minds simplify. So therefore, I'm going to show you, I'm going to go through what I'm talking about. Because you spend thousands of dollars taking a calculus course, and it's very confusing. Right? And this calculus is something they say, well, Newton invented, which is a lie. He actually got it from the original people, and he put his spin on it, and it's very complicated. And most people don't understand it. And even once you get to learn it, it's difficult to understand it and then to apply it. So I'm going to show you what calculus is really all about, right? And then you can figure out how to apply it. Let's go into it, and you'll see what I'm talking about. Now I'm going to go through step-by-step process. I'm going to explain, because step-by-step. So I'm just going to go, like I say, step-by-step, as I'm assuming that you don't know anything about mathematics at all. Let's start here. Now you got a thing called exponents. And see what things circle? That's the exponent. All that is just shorthand for telling you how many times a number was multiplied times itself. So if that number, we say x, it could be 5 or 7 or whatever. If it was multiplied times itself, then you would say 7 to the power, 2, which would call it exponents. That means just tell you multiply this times itself 2 times. If it's 3 times, you put, right, x to the third, they say power, x to the third power. So that's some way, some people say it that way. X to the second power, or 7 to the second power, right? We just tell you multiply the time itself 2 times. To the third power, you multiply itself 3 times. So the fourth power, 4 times. You understand? That's what it's telling you. That's what exponent is, a shorthand. It tells you how many times to multiply that number by itself, which would be this. So if it's 2, right? If it's 3, okay, let's move on. And so here's examples here, right? So say 4 times 4 times 4. Well, that'd be exponent 3, and that would equal 64. 4 times 4 is 16, 4 times 16 is 64. Same thing here. If you say x is 5, so 5 second power is 5 times 5, which would equal 25. If it's just 1 to the power, you don't multiply times anything, it's just 6. But 0 is a little special. It's not really special, but, right? You actually divide it by itself. So anything to 0 power is always 1, because you divide it by itself. That's a basic, basic example. Hope you just pay close attention. That's what that means. So power just how many times you multiply times yourself, right? X could be any number you want it to be, right? But all numbers have to be the same. So if this X is here 7, it'd be 7 times 7, okay? Now dimensions. There's 4 dimensions. There's no, it's 4 dimensions, not a 4th dimension, it's 4 dimensions. They say like a 4th dimension, like something above the 3rd dimension. No, there's no such thing. In mathematics, you can use mathematical formulas and talk about 4th dimension, but not in the sense of reality. There's no 4th dimension in reality. There's mathematical 4th dimensions for calculation purposes, but there's no actual 4th dimension. In our reality, in this universe, you have 4 dimensions. The first dimension is actually the 0th dimension, which is a point. It means it takes up no space at all. It exists, it just takes any, you're going to understand what that means when we get into physics. It exists, it just doesn't take up any space. Right? Then you got a line. That's the first dimension. 1 exponent. Right? That's where line, x at first, the line. X to the square, we'll explain in a minute. Right? That's a square or a rectangle. X to the second, that's dimensions. X to the third is a cube. X to 3. Well, so what this means, right? But that's the 4 dimensions that exist. A point, which that occupies no space, but it exists. A line. Maybe I should show that. No, well, I'll move on. That's another way of showing it. But anyway, I'll explain that more. We get a physics, I'll explain it if you don't understand it now. Anyway, that's the 4 dimensions that are in our universe. Okay, let's move on. See, a point, a line, a square, and a cube. And that's the mathematical equation for those things. A cube is called x to the 3rd power, 3rd dimension. A square is called x to the 2nd power, 2nd dimension. A line is 1st power, 1st dimension, right? And 0th dimension. Okay, now dimensions, that's at a point. I can show you something else. Wait 1 second. Maybe I should just do that right now before I go, because I think some of you may be a little confused on this. Just hold on for a second. Just hold on a second here. This should be pretty easy to do. I'm just going, it's not going to be totally accurate, but it'll make the point. It'll make the point, so just give me a second, another second here. Okay. And just do this here. And then I'll do it. Okay. Wrong place. Okay. Well, maybe I should do this too. Over here. I should use also. And that should make it. Uh-oh. What happened? Uh-oh. I lose my feed? boss? What's going on? Okay. Well, what happened? Okay, brothers and sisters, something's going on here. I don't know what it is. Hope you're still there, because it looks like I lost my feed. Okay. Okay, I see in a minute. Okay, I should do it. What's going on here? You stopped. I lost my feed. What's going on here? Okay, let me see what's going on here. Okay. Oh, I see. I see. Okay, there you go. Okay, I'm okay. Okay, bro, so I wanted to show you this, because I wanted to make, you understand what I mean when I say, a point occupies no space. Okay, let's see. Let's say a point occupies space. You see right here? These are, if you have a ruler, these are points on the ruler. Right? Like you have 1 inch, 2 inches, right? But where the line is right there, it's a point there, but there's no space. It doesn't take up any space. The line, the inches between this and this. But here, it exists, but it doesn't take up any space. So that helps you. That helps you, right? So this is a point here. If you look at a ruler, where the number, that's a point there, but it doesn't take up any space. Because if it did, then this would be an inch between here. Inch between here, but these points don't take up any space, but they exist. Because you said 1 here, right? When you get here, it's 1, but it doesn't take up any space. So I'll leave it there. I'll explain it better when we get to physics. I'll show you a physical, right? But it applies physically. But anyway, let's move on. And then, okay, here's a line. This is a line. This is a line here. Okay, a line has 2 points to it. See there? A line has 2 points. A line is first dimension, but it's 2 points. Like look at a ruler, it has 2 points, a point on each side. But only 1 point is relevant because the other one is just an exact copy of the other. They're mirrored. So only one is relevant, but it has 2. Understand? That's a line. To the first power, 1 dimension. Now a square, right, has area in it, right? This is a square, right? But it's made up of 4 lines. See, line here, line here, line here, line here. Only two lines are relevant because these two lines is just an echo of these two lines or mirror image of these lines. So only two is relevant. The other two just copies out that. Keep that in mind. It's x to the second power, but it's only two lines are relevant. Keep that in mind. Then get to the cube here. See? Now, cube, right, is made of six squares. You see three here, the other three is back behind those, right? Only three are relevant, because the other three are just exact copies of that. Only three are relevant, but it's third power. It's third power. Okay. I should have put something there, brothers and sisters. Okay. Right. Keep that in mind. Right. I'm just showing you, giving you a background so you understand when we get to the actual calculus part, you understand what I'm talking about. So it takes six squares to make a cube, three sides to it. Only three are relevant. Okay, so now here, remember I said a line? It just says only one point is relevant, that's one. Line is x to the first power, right? But a point is to zero power. Remember? A line, but that point, line is x first power, but a point here is just zero power. So that point is zero. That line itself is first. You understand that. Then you go to a square. I'm concerned here, bro. So am I getting a blackout here or what? Am I getting anything? Because I'm looking at I see, oh, there it is, okay. So a square, right, it's two lines, right? Each line is, right, first dimension, and it makes two lines to make it up, right? Two lines, other two lines are irrelevant. So a square is x to the second power, and it's two lines. It makes up, because the other two are just that copies of that. Okay, you follow me so far? Okay. What's going on here? Why is that showing like that? And broadcast. That's not in the way. Okay, there it is. Okay, understand that. Okay, let's move on. Now, cube, right, it's make up of six squares. You only see three because the three is in the back, right? So it's a cube, extra third power, but it takes three squares. Other three is mirror image, so you don't need them. Forget about them. Just need three squares, okay, to define it. Keep that in mind. Okay. Now, a derivative, that's something they call a derivative in calculus. A derivative, right, means you're going from one dimension to a lower dimension. You're going like the third dimension to the second dimension, or second dimension to the first dimension, or first dimension to the zero dimension. That's going down dimension. There's a thing called integral going the opposite way. We're not going to talk about that one, because every mathematical function has an opposite. Like addition has subtraction, multiplication has division. Well, in calculus, you have derivatives that's going down dimension, right? And integrals going up. Now, in each case, like addition is easy to understand than subtraction. One's always easier than the other. Multiplication is easy to understand division. And derivatives is easy to understand than integrals. And when we're talking about integrals here, we're going to talk about the derivatives for now, right? Okay. I will give you examples of it. So that's the formula for getting a derivative. So if you have a situation here where, remember you have whatever the number it is, and whatever power it is. See that little yellow thing there? That says, that means take the derivative. Like in multiplication, you have a asterisk or x. Multiplication, division, you have a, right? So in calculus, they use a thing like this, like x, right? To show means take the derivative of this. So how do you do that? Well, this is the formula for it. Whatever n is here, you put it down here, you multiply times that, then you subtract 1 from n, and that's the derivative. So here's an example. If it was x to the third power, right, then you would take that 3, multiply this times the 3, then you subtract 1 from the 3, and you end up with this, 3x squared. That's what a derivative is. That's what calculus tell you. That's a derivative. When they say a derivative, that's what they're talking about. That's how you take it. So x to the third. If it's x to the fourth, you put a 4 down here, and it beats it, right? So whatever it is, whatever's here, you put it down here. You multiply times that, and then you change the exponent up here. You subtract 1 from it. So you end up with this. This was 3, now it's 2, and the 3 is down here. And now this is what the derivative of this. I should have put that down here too. Derivative of this ends up with this. I should have put the exclamation point down here to show that. I missed that one. But anyway, derivative of this shows this. In fact, I better do that because somebody's going to come and get confused. 1 second. What is this blank again? Oh, yeah. Oh, it's showing up over there. Okay, I got it. I get it. 1 second, bro. It's just going to take a second. This. Oh, I did every place else. How come I do it there? There. Derivative. Oh, I did every place but there. Okay. 1 second here. Move for, make sure, absolutely correct. Uh-oh. Okay, there you go. Okay. Well, actually, what it is, I just can't see it, so it's so light. I should have made it darker. Let me make it darker. It was there, I didn't miss it. You just couldn't see it. So let me make it darker here. Okay. You just couldn't see it. So let me see what I can do here. What I can do with this. No, can't do anything with it. Give me that help. Still can't see it too good. Got another one here that I can use. Okay, I just have to go with that. You see it, brothers and sisters. Just too late, you can't see it. Let's make sure it's absolutely correct. Okay. So, the derivative of x to the third is this, comes to 3x squared. If that formula, that's the formula for derivative all the time. Doesn't change, that's the formula for derivative. For integral is a different formula. But we're only going to talk about derivatives here. Okay, go to the next one. Let's see, so here it is. Now here's the derivative of a line. You follow that formula and you get a point. Remember, you're going down a dimension. Derivatives means you're going down a dimension. Going from one dimension down to the next one. So you go from third dimension to the second dimension, or the fourth dimension to the third dimension, or third dimension to the second dimension, or second dimension to the first. So if you go derivative of the first dimension, you're going to end up at the zero dimension, which is a point. Derivative of this is a point. So here's a line. Derivative will be a point. Okay? Now, a point, you have to show it here, but the point is you couldn't see a point, because a point doesn't take up any space, but for graphical explanation, right, I have to put there, but actually you can't see a point because it doesn't take up any space. See? So, but this is, this is demonstration here. Okay. Let's move on. Okay, so now the derivative of a square, right, is this. Two lines going down a dimension. To follow that formula I told you, right, you put 2 over here, subtract 1 from that, and you get 2 lines. X1 is lines. That's dimensions, see? So you got 2 of them. You might notice a pattern at this point. You got 2 of them. Let's go back and look at the previous one, right? Remember, you had 2 points for a line, but you take the derivative, you only got 1 point. But because only one was relevant. Only one was relevant. So here, you have 4 lines, but only 2 is relevant. So that's what it says. Take derivative, and you get 2 lines. Down a dimension, you get 2 lines. That's the derivative of this. You get that, okay? 2 lines. Get derivative of a cube, and you get 3 squares. Follow that formula, 3 squares. 3 of them, 3x squared. 3 of these, 3x squared, 3 of them. That's what you got, 3 of them. Remember, you got 6, but only 3 are relevant, because others are mirror image. Okay. So now let's get to what this means. So that's calculus is. That's what I showed you is the formula for calculus for derivatives. Now they're going to charge you $6,000, $10, whatever, a whole semester, and tell you all this stuff about derivatives, all kind of stuff. And I just showed you. It's simple. The graphic. What a derivative is. But they're going to give you they're going to take a whole semester trying to explain what a derivative is and give you all these explanations. I just told you it's simple. But spatial mind is just going from one dimension to a lower dimension. So all it is, right? From one dimension down to so I'm going to show you how it works, how it applies. See, because that's the tool. Calculus is a tool. It's a tool for how to deal with the mathematics of our existence. Because everything is mathematics. Calculus is a tool to how to deal with it. You have language like vectors of language, but calculus is a tool. Calculus is a tool, right? And it encompasses all other stuff, division, multiplication, all that stuff. But calculus is a tool. Now I'm going to show you, give you an example. Now, once you learn the tool, like any tool, like hammer, you can find all kinds of use for your hammer. Or pliers, once you understand how to work the tool. Once you learn the tool, then you guys look at, because everything you find, you can apply this to. Everything, I'm going to show you the simplest way, right? So mass times velocity is called momentum. Mass times velocity is called momentum. But mass times acceleration is called force. That's the formula. Mass times acceleration equals force. See? And I think I missed something here. Oh, let me see. I think I missed something. If I did, I have to put it in here. Yep, I did, I think. Could have myself here. Yep, I did. Okay, I'm back up. I gotta show something here, brothers and sisters. I don't know how I missed that one. I ain't making no excuses, but I'm gonna say it, but I should show it here. That's the line. Let me see. Oh, I'm going the wrong way. I really need to show the equation. Okay, give me a second, bounce this one, but it really won't take but a second. see that so I can see what I'm doing here. Okay, where is that at? Mass acceleration. Is that it? Well, not that one. Not that one. Okay. Do it this way. Okay, I just add another page here. Where is it? That's it. Right there. Okay, what I need to show is acceleration, okay, velocity. No. Okay, get out of the way. And move this out the way. Yeah, where's that? Oh, it's out the way here. And flip it here. Move up here and get this. Okay, almost there. Okay, there you go, there you go. Okay, and then let's do the formula. Let's do the formula, okay. Oh, right this one here. Right. Okay, almost there. There you go, that's it. Okay, there you go. Okay, this is why I didn't show. I need to show this wrong system. Make sure you, I missed this one. See previous. Now I said mass times velocity equals momentum. Right? Mass times acceleration equals force. Right? So let's look at that. Now what is acceleration? The derivative of velocity, remember? The velocity is called x to the first power. Because the line is moving, see? Velocity is called, like you driving down the road at a certain speed, 50 miles an hour. That's velocity. Understand? And velocity is like a straight line, so it's called x to the first power, straight line. That's applied to mathematics. So acceleration, if you take the derivative of that, it's a point. So where's the point? Where's the point in that situation? Okay, we'll see that in a minute. But anyway, that's the equation. Now they tell you, go to calculus, they tell you the derivative velocity is acceleration. Now, that's not making up here, I'm just showing the simplicity of it. But when they finish telling you, you'd be so confused, you understand how anybody talked about how it applies. I'm showing for spatial, and everything I showed you right now, you'd be in there 6 weeks or a whole semester, and you still wouldn't understand this. Understand what it's talking about. I'm showing you the simple way, the spatial way. The analytical way, that's their way. Simple minds complicate, complex minds simplify. Okay, so I said velocity is a line, right? And acceleration is a point. I just showed you the math there. I didn't have to show it before. I showed you the math. And back up, brief, right? Right? I'm saying velocity, derivative velocity. If you take the derivative, right, that'd be one down here, change to make it 0. That'd be a point. So that's how you get acceleration, is the derivative velocity, right? Acceleration is a point. Okay, let's see what that means. Right? Now velocity is a straight line again. You move it down 50 miles an hour, that's velocity. Now if you slow down, that's not velocity anymore. Because velocity means you gotta be going at a certain velocity means you at a certain speed continuously. If you slow down, speed up, change direction, that's acceleration. That's called acceleration. You know, it used to call, when you put your foot on the gas, you used to call it an accelerator. I don't know what they call it anymore. Maybe they still call it the same thing. Because they'll use power, and then you could, right? You give power to it, so you can step on the gas, you can slow down, you can pull up off of it, right? Okay. So keep that in mind now. So here, see here? Here's velocity. Now when you get right, now say for instance you change direction. That's called acceleration. Say you speed up. Remember this line is longer than this one. When you're talking about vectors, right, the longer the line, so this means it's going faster now. So you sped up, right? Or you slow down. The other one means you sped up because it's longer than that one. He's going here, now he's going 50 miles an hour, now you're going 60. Or you was going 50, now you're going 30. That's the red one. Or you change direction. But in every case, you had to stop going at 50 miles an hour. You had to stop going 50 miles an hour. To change direction, right? You have to stop going 50 miles an hour in that direction. If you change direction, right, then you're not going, if you're going 50 miles an hour north, and now you're going 50 miles an hour northwest, you had to stop going at 50 miles north. You had to stop doing that to go to a different direction. You had to stop going at 50 miles an hour to move up to 60 miles an hour. You had to stop going at 50 miles an hour to slow down to 40 miles an hour. You had to stop doing what you was doing. That's what acceleration is. To stop means you had to come to a point. A point. You understand? You had to come to a point. You had to stop what you was doing to do the next thing. Right? Or even if you hit a brick wall, you still had to stop. You're going 50 miles an hour anymore. That's what's called acceleration. That's the mathematics of it. It works perfectly if you do the math. Car related. Once you understand the math, you understand this, then you can calculate this stuff. That's what it means. Yeah, they're going to spend 6 months, whatever, and you might spend 2 or 3 years learning. You will understand it. As simple as that. You stop doing, when you stop, I mean, the point. You ain't doing what you was doing before. Come to a point. So then you change. That's what acceleration is. Mathematically, that's exactly what it is. Okay, so let's look on. Okay. And see here? Boom. Now that's it when you stop all together. So they say mass times acceleration equals force. Okay, so mass is how big the car is. Or how big you are. That's the mass. So once you once you calculate the acceleration, then you just multiply how big the force is. The bigger the force is greater. I mean, how big the mass is, right? So you say a Big Mac truck is going to be at going 50 miles an hour. It's going to be more force than a Volkswagen Beetle going 50 miles an hour. That's what mass is. So that's like it's called a scalar. You just how much it is once you determine the impact of force, then how much is it? So what happens here is that I showed you if you change direction or if you slow down and speed up, or if you hit something, you still come to a point. But to come to a point like that, even when you change direction or you speed up, slow down, you still had to stop what you're doing. You still had to apply force to do that. To change direction, you had to apply force to do that. To slow down, you had to apply force to do that. To speed up, you have to have force to do that. Right? So mass times, but this is the simplest way of looking at it. If you hit a brick wall, then it's force. You turn that velocity into force because it turns to a point. It had to be something to stop it. It had to be something to stop it. Right? Brakes or something had to stop it from doing what it was doing before. And that's called force. Basically, understand the force. The force will stop you from doing whatever you're doing, right? One force will stop you doing whatever you're doing. It takes a force to stop you doing whatever you're doing. If you're doing something, it takes force to stop you from doing it. So it takes force you stop going 50 miles an hour to change to go to 60 miles an hour, or to go 30 miles an hour, or change the brakes. Because you had to stop a force. It's force to stop you doing it. So you hit a brick wall, right? Velocity, it turns to a point. So that's force then. If you hit something, anything stop, whatever you stop doing what you was doing, that's force. It takes force to do it. And that's the calculation. Let me show it again. See here? Oh, and back. Yeah. Here's velocity, boom, turns to a force hit, force. Because hit stop, it's not moving anymore. And that's how you calculate force. Now I'm showing how the tool works. Then the genius of it is finding how to apply it. I just show you how to apply it when you're driving on a car or you're driving or you hit something. The simplest way. How you apply it for that. Why they say mass times acceleration equals force. That's why. Because that's not some guy's idea they think it works. No, that's exactly mathematics work. I said everything's mathematics. Exactly how it works. So you can calculate the force of something if you understand if you say how fast it's going, right? And what happened when if it hits something, you can calculate. And all you gotta do is figure out how fast it was going and how big it is. And then you can determine how much force impact it had. Or it will have if it hits something. That's the tool. That's the basic tool. See, they take all year to try to get you to understand the basic tool. Once you understand the basic tool, then you can say, okay, find a situation where you can apply that. Because believe me, you would be surprised. Your computer, when they make cans, when they tell you make some vegetables, you want you manufacture, and you want to. Okay, now you got your product, but now you want to put it in cans, so you can sell it. Well, it's a calculus formula they use to determine what size can, what material they should use, right? What size can, and the construction of the can. That's why you go and see some stuff. It looks like fancy little containers. Somebody just say that's cute. No, they did the calculus. And they came out and said, if you design it this way, it's going to be the cheapest way, least expensive. Because, man, if you want to sell your product, you don't want to spend a whole lot of money on the damn can. They can't eat the can. Can just holds it. So you want to get the minimum. You want to be able to store it, right? And you want to have the cheapest container you can find. And so calculus is called a maximum minimum. Right? I'm not going into that. It's a maximum minimum of formula in calculus. And that term that tells you, it should be 3 by 5, or and it should be round or square, right? And this high and made of aluminum. That's power calculus, right? How much water, how much pressure, water. I'm not getting that kind of stuff, but I'm just showing you that's now people figure out once you understand how the tool works, because that's what they're going to try to treat you and then try to give you some examples. Now, once you understand how to work, then you're going to get your calculus book, Calc for Dummies or whatever, and maybe you understand it now, instead of going how they explain how calculus works, because you don't need that. You know the tool now. So now you go and see how they apply it. Then you can go in these books and see how they apply that. See, let me one more thing here, bro. Since I'm going to close, I said, I hope I spend more than an hour. I want to do more outreach at one of these, because tomorrow I want to do pressure. But watch this. Oh, force pressure. I didn't mean to put that. That's the wrong title. See here, boom. Here's another. See, that's force. Hit something, right? And that velocity hit, right? It turned into force. But since it turned into force like this, it's force spread out. Remember the other case, it turned to a point, right? Actually, let me go back and show this. I probably should have did this way when I think about it. I'm showing what turned to a force, right? But you can show an arrow coming out of here. I didn't want to confuse you by doing that, but just the force in here. No, let me leave it like that. No, I did it right. I'm thinking about that, no. But in this case here, right, it turns to a point. But then it changes, right? So it turns to a point, but now it's spread out. So it's not like it was. It's spread out now. So now it's still force, but it's called pressure now because it's spread out. That's why they're taking planes or like skiing and all that kind of stuff. The skis because you put your weight on it, and the reason why you don't go fall down in the snow, because it took your weight and the spread out. So instead of you standing on some snow, right, and you say you you're 200 pounds, you put 200 pounds on that one square, say one square foot, right? You put 200 pounds on one square, well, right? Or even if you're in some water, you go right through because that square can't handle 200 pounds, right? But say it can handle 50 pounds, right? Well, so if you lay down and spread your weight out over 4 square, then each only have to handle 50 pounds. So therefore, you won't sink. That's why I have skis. They spread your weight out. Water skis, regular skis, they spread your weight out. Boats, same thing. They spread their weight out. So, because if you take a broomstick made of solid steel, and say we're 1,000 pounds, if you sit up right on your floor, it's gonna put your hole through the floor because your floor can't handle 1,000 pounds in like 1 square inch like that. It wasn't designed to handle that kind of weight. But if you lay it down, then you spread out over the whole floor. Then, depending on how long the room is, now you got, instead of 1,000 pounds or 1 square inch, now you got maybe 100 pounds per square inch, right? Because you got 100 square inches out. You understand what I'm saying? So I hope you understand, bro. So, let me see here. Let's go here. Okay, and okay, bro. So that's pretty much it. Now that everything I told you is absolutely correct. Don't go check it out. But you can teach your children that's calculus. What it really means. They won't tell you when you go to school that it's going from one dimension to another. But you see it right there. It's right there in the math. Calculus going from one dimension to another. That's what it's all about. And everything creation, right? It's like there's certain. When you talk about the races are derivatives of each other. See, you got the highest dimension. They're derivatives, but I don't want to go too deep into that right here. This is for calculus, right? But all animal life and everything is derivatives of another. When you understand the math of it, right? See, and you find derivatives. Like I said, I showed you I showed you in a sense of force, but it's also, like I said. People, races are derivative. One race, other races, derivative from other races. They came out of other races, derivative of it, right? And I never got. Well, actually, I shouldn't even say that right now because I never discussed that before. I didn't want to get that's advanced math, and I didn't want to get into it because nobody's been able to handle regular math. That's advanced math, but you can prove it mathematically, right? So. There's all kinds of ways. I mean, once you understand once you understand the tool, then it's up to you. Even in music, there's music that's derivatives of music. Everything has derivatives. Derivative means you take it down to a dimension lower than it was. So it doesn't have all the properties of the first one, but it has something similar to it. So you have DNA. Animals are derivative of us. Because they have the same, less DNA, down dimension. So it's up to you, once you understand the tool, and you get better and better, once you start doing it, you get better and better about how to apply it. Because Islam is mathematics and mathematics Islam, and when you get home, you will have to you will not be able to survive if you don't know this tool. It's like you can't survive in this society if you can't read or write. this was a tool you have to know. It's like verbs and pronouns and nouns, all that kind of stuff. You need to know that. And you need to know vectors, you need to know calculus, because calculus is, like I said, the tool. So you have, if you, and I showed you the spatial message, spatial method. Analytical, it makes it complicated and nobody understands what they're talking about. Most of the time they don't understand either. But they can use it, but they don't know how to apply it to our life situation. That's their problem with math. They don't know how to apply it to our life situation. Or they know how to apply it to gadgets and machines and stuff like that. But when it comes to our reality, they don't know how to do that. And maybe they haven't thought about it. You sure ain't gonna, well, you ain't getting these fools out here that claim they teaching and they have no idea about any of this. So like I said, check it out. Just tell me, show me. I give you $1,000 if you show me anything I said was wrong. That's calculus. That's the derivative. That's the up dimensions integral. Nothing against that. It's more complicated, right? It's just going another way, like division. It's going another way from multiplication. Some people have a problem with multiplication, but they have a little difficulty with division because some people have no problem with addition, but they have a little problem with subtraction, right? And even though it's the opposite, because they get into negative numbers and stuff like that. See, you get very complicated on the subtraction side. When you get into negative numbers, you don't have it on the positive side. Right? See, so it's more complicated than integral. I'm not against that, but the derivative. That's the most common use of it. And you can do all kinds of things with it. Once you study it, learn how to learn the tool, then you got to learn how to use the tool. Somebody can tell you, oh, here's a tool, right? And tell you all the things about tool. Like somebody can teach you all about the violin, right? All about the violin. But now, how do you go out and make some music? So, I know you know how it works, strings and notes and all that kind of stuff. But now, do you know how to go out and turn into music? And I just gave you the tool. That's the tool. Right? Now they get all fancy and everything with it, go complicated. And if you talk to most black folks, I don't know about math, I ain't good at math because they taught it. And I give a short example here. If you are right-handed and you live in a society that's totally left-handed, everybody's left-handed, everything you do is left-handed. And you have to use your left hand. You're forced to use your left hand for everything. You'd be at a disadvantage, wouldn't you? Everybody be at an advantage to you because your right hand, where your power is, you can't use it. Because everything's, so you're a guy, you go with your left hand, and everybody else, that's their power hand, left hand, so they're going to always be ahead of you. That same thing here. They're teaching you analytically, which is the left hand, and that's why you don't understand what they're saying, and so we'll complicate it to you. You see? But you're spatial. And so and it's confusing to you. And that's my job, to bring this spatial side to you. Your side, your right hand. Because right now you're in a left-handed world. See? And the left, put it this way, we be left-handed, right hand, where we going, but the right hand will dominate. Right now, left hand is dominating, separates you confused. You're up on your weak side. See? So you can operate, but it's difficult, because everybody else is easy, man, that left hand is easy. But for you, it's difficult. So we're going to a world right-handed. You understand? That's what I'm trying to bring you to. So I just gave you two. So if this means anything to you, I suggest you do. Like I said, I'm just going to give you the tools. What I suggest you do is go get you one of those Calculus for Dummies or whatever books and see how they apply it. So now you can see application. Then you can see use this, what I just showed you, to apply, and you find it much easier. And you understand what you're doing. Like I told you, a simple example, a lot of people can't get that one. About mass time acceleration equals force. That concept, And then, and it's a simple concept in mathematics. That mathematics is accurate. It's not like, oh, it should work that way. No, that's exactly how it works. Exactly. The mathematics is exact. Exact. She said, wow, it works like that. That's exactly how it works. Mass times acceleration force. And velocity, the derivative of velocity, is acceleration. So you're going down the street, 100 miles an hour, you put on the brakes, acceleration. Speed up, acceleration. Change rate, acceleration. Took a force to do it. Assalamu alaikum, brothers and sisters. Hopefully tomorrow, the next one, I think I'll do pressure, but I may do something else, but right now I'm thinking of do pressure tomorrow. Hopefully I can take an hour each day to do this, aside from my regular presentation. But I'm going to start bringing, I said, mathematics. Islam is mathematics, mathematics Islam. Now, I told all these fools out here talking this stuff. Tell them to teach you some mathematics. They talk all this stuff. They speaking directly to Allah. They know everything. Sunnis too. They know they speak directly to Allah. Allah speak. They get the Holy Spirit, and they know everything. And they got Mr. Black Man, and they got the supreme wisdom. Well, tell them to teach them mathematics. If Islam is mathematics, tell them to teach them mathematics. Because this whole course I'm doing right now is going to be all mathematics. We get in physics, we're going to get gravity, we get all that stuff. And not going to be theoretical. Because you're going to find out there's some of that stuff out there, like quantum mechanics and gravity, they're theoretical. I'm going to get actual math. And I dare anybody to show me I'm wrong. I pay anybody $1,000 to show me I'm wrong. Because Einstein's theory of gravity is wrong. It works, but it's wrong. Quantum mechanics works, but it's wrong. Remember, the Romans built great bridges and everything else, but they didn't understand math. There wasn't no zero in their mathematics. But it worked, but it was wrong. A lot of things, you get a lot of things to work, right? Well, maybe I should say it's not accurate. I mean, I should say, because if it works, let me phrase that. See, Einstein's theory of relativity, right, is a theory. But if they say it's only wrong if they say it's a fact. No, they say it's a theory, right? It works, but it's not accurate. They get stuff out of it, right? The same thing with quantum mechanics and quarks. Quarks don't exist. That's wrong. But they can get it to work because that's. But if they do the mathematics of it, they could make it work even better. You see, because once you get mathematics, it means you get more information out of it. Once you learn it, the more you better you learn to use that tool, the more you get out of it. Okay. So I'm gonna give you mathematics, and we can talk about theory. I'm gonna give you a theory of gravity. I'm gonna show you exactly what gravity is. I'm gonna give you a theory of atoms. I'm gonna show you exactly what atoms are. And I dare anybody to prove I'm wrong. $1,000 for any scientist, anybody come out there and show me I'm wrong. Nobody's done it yet. And that's what this is going to be. I'm trying to do it an hour each day, right? So like tomorrow, I think I'm going to do pressure tomorrow, but I may do something else. Hope you understand, brothers and sisters. Assalamu alaikum. Then you got to learn how to use the tool. So like tell you, well, here's a tool, right? Tell you all the things about the tool.
this,